The domain name system, or DNS, is commonly referred to as the phone book of the internet. Why? Well, since computers communicate via IP addresses, it would be extremely difficult for us to remember a bunch of numbers whenever we want to visit a site like Google or Facebook. In comes DNS, which maps these easy to remember names to IP addresses. A domain name is made up of sections separated by periods. The rightmost section is the top level domain, or TLD, and these can be country code TLDs like .au, .us, .uk, or general TLDs like .com, .org, .edu, .gov. There are currently over 1,500 top level domains. The section directly to the left of the TLD is the secondary level domain, and you're probably familiar with ones like Google, Facebook, Meta. Anything to the left of the secondary level domain is a subdomain, and some common ones are www, blog, mail, app. Now, strictly speaking, when all of these sections are combined, it is known as the fully qualified domain name, or FQDN. But in most cases, people will just refer to it as the domain name. So how do we resolve domain names to an IP address? Well, when you try to visit a website like google.com, your computer needs to know the IP address of the server that hosts these resources. So your computer sends a DNS query to a DNS resolver, also called a recursive DNS server, asking for the IP address of the domain. This resolver is often provided by your ISP, but you can also use public ones like Google or Cloudflare. The resolver receives this query and then queries a root name server for the address of a DNS server for the top level domain, in this case .com. The root server then sends back an IP address for a top level domain DNS server. Our resolver then queries the TLD server, asking for the IP address of an authoritative name server for the domain name, and the TLD server will respond with an IP address for the authoritative name server. The resolver then queries this authoritative name server, which contains the actual IP address of the domain name, and the authoritative name server responds with the IP address of the domain to the resolver, which in turn passes it back to our computer. So now our computer has the IP address for google.com and we can access the website. All of this happens in the blink of an eye, but we can reduce the number of queries by caching this record, and this would commonly be cached by our browser, operating system, and DNS resolver, so that when we, or another computer, requests the IP address for the same domain, the response can be even quicker without completing the full chain of queries. An important thing to note is that these cached records will have a time to live, or TTL, which instructs the computer or server how long it can cache that record before it has to perform the full chain of queries again. Speaking of records, there are a variety. The most common ones are the A record, or address record, which contains the IPv4 address of the domain, the Quad A record, which contains the IPv6 address of the domain, the CNAME record, or canonical name record, which contains another domain allowing for domain forwarding, the MX, or mail exchange record, which contains the email servers for this domain, the NS, or name server record, which contains the authoritative name servers for this domain, the SOA, or star of authority record, which contains important metadata about the domain such as the email address of the domain administrator, the TXT, or text record, which can contain arbitrary information but is commonly used to verify ownership of a domain to third parties. And if you want to see the DNS records for a particular domain, you can use an online tool like DNS Checker, which will show you all the DNS records for that domain, including their values and TTLs.